A very good morning to all. Today's topic is air pollution. Okay, so in the previous classes, we are discussing about the elective paper. So here in that paper, we are discussing about some of the topics. Okay, that is about green chemistry. We are discussed, as well as the second is organic chemistry. In that organic chemistry, we are discussing about the pericyclic reactions. Then today's topic is environmental chemistry. So here in this environmental chemistry, we are discussing how air pollution is taken and which gases are in air pollution. Okay, so discussing today. Let us see. The air is never found in nature in this. This may be due to the natural happenings or due to human activities. Many gases and solid particles are continuously released into the atmosphere through human activities. As a consequence of industrialization, vegetation, decay, and forest fires may also causes in the quality of the air. These harmful gases and solid particles entering into the atmosphere are called as air pollution. Once I repeat, the harmful gases and solid particles entering into the atmosphere are called as air pollution. These are present in the atmosphere in concentrations that disturb the ecological balance. This is turn affect man and his environment. Then the primary pollutants and their sources. What are the primary pollutants and what are the sources of the here look at this carbon monoxide, nitrogen oxides, sulphur oxides, hydrocarbons, particulates, carbon monoxide. Okay, so these five are the primary pollutant particles. So here today we are discussing about the carbon monoxide. How the carbon monoxide pollute the air or atmosphere. Okay, look at this, the carbon monoxide. So this is the major individual pollutant entering into the atmosphere. It is a colorless, odorless, and poisonous gas. It is as solid carbon monoxide, the and incomplete combustion of fuel or carbon containing compounds. Generally, in so many vehicles are there. In those vehicles, we can use fuel. So the incomplete combustion of fuel, the carbon monoxide gas is produced. How the carbon monoxide? The carbon is reacted with the oxygen, then it is converted to carbon monoxide. The second one is reaction between carbon dioxide and carbon containing materials at elevated temperature. The carbon dioxide, it is reacted with the carbon particles. It is also converted to carbon monoxide. The third one is dissociation of carbon dioxide at high temperature. The carbon dioxide is dissociated to carbon monoxide and oxygen radical. So in these three combinations, the carbon monoxide is released to the atmosphere. And what are the sources of the releasing of carbon monoxide? The natural process. Volcanic eruptions. When the volcanic eruptions are produced, at that moment they release the carbon monoxide. And natural gas emissions, electrical discharges, doing storms, and so seed germination also. Seed germination, in that process also they release the carbon monoxide. These are the natural process. Okay. What are that? Volcanic eruption, natural gas emission, electrical discharges, doing storms, and marsh gas production, as well as the seed germinations. Then how a human release the carbon monoxide? The transportation. In the transportation, we can use the motor vehicles, aircrafts, railroads. Okay. So by the transportation and by the forest fires, by the agriculture burning, okay, and industrial process, the carbon monoxide is entering into the atmosphere. Then what is the sink? The soil microorganisms. Then hazardness, how it get harmful into the body. Generally, the carbon monoxide, it is reacted with hemoglobin and replace the oxygen to form carboxyhemoglobin. When the oxyhemoglobin is reacted with carbon monoxide, then it is converted to carboxyhemoglobin. So this carboxyhemoglobin, it is the stable structure. Due to the stable nature, when it is enter into the body, the person who get this type of combination, he unable to breathe properly. So that's why the death condition takes place. Next, initial effect of carbon monoxide is poisoning is loss of awareness and judgment. What are the biochemical effects of the carbon monoxide? What are the carbon monoxide level and how it is affect to the atmosphere or to the body? If the carbon monoxide level is 10 ppm, loss of judgment and partial loss of vision takes place. If it is raised to 100 ppm, headache, dizziness takes place. It is 250 ppm, loss of consciousness takes place. So just like if it is 1000, the rapid death also produced. So these are the conditions. If the level is increases, how a body is infected. Then what are the remedial measures? The first remedial measure is that the carbon monoxide tests for automobiles and prevent bad vehicles to run on the roads. Once I repeat, the carbon monoxide test for automobiles and prevent the bad vehicles to run on the road. Use of masks. The third one is exposure of affected persons to fresh oxygen. The people who are affected with the carbon monoxide, then we can give some amount of the fresh oxygen to them. So that's why the death conditions are decreases. Then the next air pollutant is nitrogen oxide. So the different types of nitrogen oxides are there. Generally, we can discuss about the nitrogen dioxide as well as nitric oxide. NO is nitric oxide, NO2 is nitrogen dioxide. So here the nitrogen oxide is used as a symbol of nitric oxide as well as nitrogen dioxide together. These are primarily involved for air pollution. The natural bacterial action discharges both 5 into 10 to the power of 3 tons of nitrogen oxide in the world every year. Okay, from the natural bacterial action, 5 into 10 to the power of 3 tons of nitrogen oxides are released to the atmosphere. The human activities, they also release 5 into 10 to the power of 7 tons. But the amount varies depending upon the urban and rural areas. In urban areas, the nitrogen oxides released is about 100 times greater than the released in the rural areas. That means the urban area can release the nitrogen oxides very heavy, 100 times greater than the rural areas. The human activity mainly related to combustion of coal, oil, natural gases, and gasoline. Power plants, they release 4 million tons per year. For industry can release 4.8 million tons per year. The domestic and commercial heating plants release 1.2 million tons per annum. The average residence time in the atmosphere is 4 days for nitrogen, 4 days for the nitric oxide as well as the nitrogen dioxide is 3 days. In urban areas, before daylight, the nitrogen oxide level remains stable. In urban areas, before light, the nitrogen oxide level is remains stable. But between the 6 to 8 a.m., the level of nitric acid increases and reaches maximum. At mid-morning, with increased UV level, the nitrogen dioxide level increases due to the conversion of nitric oxide to nitrogen dioxide. In the evening, the nitric oxide level goes up again. What are the hazards caused by the nitrogen oxides? The nitric acid is less toxic than the nitrogen dioxide. Like carbon monoxide, it also forms bond with the hemoglobin and reduces oxygen transport efficiency of it. The nitrogen dioxide is more harmful to human health and it is nitrogen dioxide is more harmful to human health when comparing with the nitric oxide. The biochemical mechanism of nitrogen dioxide is not clear. Probably some cellular enzyme systems are disrupted. A possible antidote of vitamin E. What are the biochemical effect of nitrogen oxides? So here in the previous we are discussing about the carbon monoxide levels. Here we can discussing about the nitrogen oxide levels. If the nitrogen oxide level is 50 to 100 ppm, what are the effect of human health? Inflammation of lung tissues can be affected, and if 150 200 level is increases, ppm is increases, then branchiolitis fibrosa, obligerals fata if exposure is for 3 to 5 weeks. If 500 ppm or more ppm nitrogen oxide is present in the atmosphere, the death also causes. The nitrogen oxides removal from stable gases is possible only through the chemical treatment. Sulfuric acid or alkaline solution containing calcium hydroxide, magnesium hydroxide can absorb the nitrogen oxides gases. Okay, so it is about the what is the how nitrogen oxide is affected and how it is released, how we can prevent from the nitrogen oxides. Next one is sulfur oxides. So the various sulfur oxides are present: sulfur dioxide, sulfur trioxide. The mixture generally referred as sulfur oxides. What are the sources of sulfur oxides? The natural process, how sulfur oxides are produced by the natural process, by the organisms are responsible for 70% of the pollution. That means 70% pollution of sulfur oxide is spread all over the globe. Then how sulfur oxides are into emissions? These sources contain about 30% in the urban areas. And reduction of sulfur oxide is 1 to 10 to the power. The next one is so sulfur oxide, it is in the combination of SO2 and SO3. How in the natural process also sulfur oxide gases are produced by the volcanoes eruption. By the man-made also the sulfur oxides are introduced into the atmosphere. Per annum, the 10 to 1.5 into 10 to the power of 6 tons of sulfur oxide atmosphere, as well as by using the fuel combustion, that means by the coal also 74 is produced 75%, as well as by the industries, they contribute the 22% of sulfur oxides by the sulfuric acid, and the transportation also produce 2%. Okay, by the man-made also they can produce. How? That means by the fuel combustion, 74% of sulfur oxides are produced. By the industries, 22% of sulfur oxides are produced into atmosphere, as well as by the transportation, the 2% of sulfur oxides are entering into the atmosphere. The much of nitrogen oxides as well as sulfur oxides entering the atmosphere is converted into nitric acid and sulfuric acid in photochemical reaction. They are responsible for acid rain. Okay, if the nitrogen oxides as well as sulfur oxides are entering into the atmosphere, by the photochemical pathway, they are converted to nitric acid and sulfuric acid. By the combination of nitric acid as well as the sulfuric acid, the acid rains are produced. Okay, so these are the reactions of the formation of sulfuric acid as well as the nitric acid. That is, the nitric acid is reacted with ozone, then it is converted to nitrogen dioxide. Reacted with O3 to nitrogen pentoxide. Nitrogen pentoxide is reacted with then it nitric acid as well as sulfur dioxide injection is reacted with then it is converted to sulfuric acid. So the combination of nitric acid and sulfuric acid can produce the acid rains. Okay. Then what are the biochemical effects of sulfur oxides? The sulfur dioxide is mainly responsible for air pollution. This is experienced by many. The most widespread disaster occur when sulfur dioxide is accompanied by smoke. This is known as smog. In London, the 4,000 deaths are occurred in December 1952 on account of this smog. The cause of death were bronchitis as well as pneumonia and allied respiratory problems. The sulfur dioxide is injurious to plants also. It causes destruction of leaf tissues. Chronic exposure to sulfur dioxide causes chlorosis. Chlorosis is nothing but bleaching of green plants. The sulfur dioxide causes acid rain, which damage plants besides aquatic lives in rivers as well as lakes. How to control sulfur oxides? The first one is that if we can removal of sulfur oxide from fuel gases. First, we can remove the sulfur oxide from the fuel gases. The second one is The removal of sulfur from the fuel. If we can remove the sulfur from the fuel, then there is no elimination of the sulfur oxides. The use of low sulfur fuels also useful because they can release a little amount of the sulfur oxides. The use of non-conventional energy sources in place of fuel. In the place of fuel, generally in nowadays, the electrical bikes are produced. If we can use bikes, they could not produce the fuel. Okay. So these are the prevention methods by the atmosphere by the sulfur oxides. The next one is about hydrocarbon pollution. Organic compounds containing only carbon and hydrogen are known as hydrocarbons. In suppose alkenes, alkynes. So in these cycloalkenes, whatever these are having only hydrogen and carbon moiety. So that's why these are called as hydrocarbons. Okay. Trees emit large amount of hydrocarbons in the atmosphere. For example, methane is the major naturally occurring hydrocarbon emitted into the atmosphere. Okay, generally the methane is the major hydrocarbon which is emitted into the atmosphere. In the anaerobic decomposition of biomass in water and soil by bacteria, large quantities of methane also released. If we can take aldehyde, in the presence of the bacteria, it is converted to carbon dioxide plus methane. The domesticated animals contribute large quantities of methane. That means the domestic animals can also produce the methane. The residence tunes of methane is as large as 3.7 years in the atmosphere. The human activities also contribute a large quantities of hydrocarbons. Automobiles are also produce major amount of the hydrocarbons. That's why they are also sources of the pollution of hydrocarbons. These hydrocarbons from human activities are generally found in higher population density areas. For example, about 200 deficient hydrocarbons are identified in this context. These are ethane, ethylene, acetylene, propane, N-butane, isopentane, toluene, N-pentane, M-xylene, and isobutene. So these are the some of the examples of the hydrocarbons. So here, what are the sources of hydrocarbons? How the hydrocarbons are entered into the atmosphere? This petroleum can produce 50% of hydrocarbons. Coal produce 4% of hydrocarbon. Wood produce 3% of hydrocarbons. Refuse foaming, it produced 29%, and solvent evaporation, the 2% of hydrocarbons entering into the atmosphere. And what are the hazards caused by the hydrocarbons? The harmful effect are not directly caused by the hydrocarbons. These are from the products of photochemical reactions in which hydrocarbons participate. The hydrocarbons do not react with the light directly, but the photochemical oxidants in the atmosphere are responsible for this. That means the hydrocarbons are directly not reacted, but in the presence of the photochemical, these hydrocarbons are reacted and they produce the different combinations. These are the source of photochemical smog. The smog is an odd combination of smoke as fog. By the combination of smoke and fog, the smog is produced. The photochemical smog is oxidizing smog having high concentration of oxidants, brown fumes, which irritate the eyes and the lungs characterize this smog. This causes extensive damage to plant life. The probable mechanism of smog formation can be illustrated as follows. Number one is hydrocarbons containing carbon-carbon double bond. They released from auto exhaust interact with ozone to form hydrocarbon free radical. Combination with oxygen to form aldehyde, parasite, and radical. This RCH2O2 react with the nitric acid to form the nitrogen oxide as well as the aldehyde. This aldehyde react with the oxygen to yield aldehyde and water, HO2 free radical. This HO2 free radical is reacted with nitric acid to give the nitrogen dioxide and OH free radical. So this type of cycle should be takes place. But the aldehyde may initiate another route by the interaction with the hydroxyl and forms RC double bond O. This react with the oxygen gives a free radical. Finally, the peroxyacyl nitrate is formed by the reaction with the nitrogen dioxide. This peroxyacyl nitrate, PAN, is the most harmful pollutant. Okay, by the combination. Look at this in this. So here in the combination, the hydrocarbon, it is produced a harmful product that is called as PAN. PAN is nothing but peroxyacyl nitrate. What are the biochemical effect of this PAN? PAN is nothing but peroxyacyl nitrate. So this is the product of photochemical smog. This causes irritation of eyes, respiratory tracts of human beings. Enzymes are most affected by this PAN. Cysteine is badly affected by the PAN. The enzymes involved in citric acid cycle are also affected most. The enzymes with synthesis cellulose and lipids in plants are also affected most. The control of hydrocarbons. and photochemical smog. The pan formation is controlled by the preventing the formation of hydrocarbons and nitrogen oxides. Then only we can prevent the pan, and then only we can avoid the diseases. The oceans, sulfur dioxide is transferred to the ocean via the formats of sulfuric acid. Some plants even metabolize the maize, grassland, bean, and alfalfa show uptake of ozone, sulfur dioxide, carbon monoxide, nitrogen dioxide. The next one is about particulates, which are called as particulates. The small solid particles and liquid droplets are collectively termed as particles. Okay. Then what are the natural source of particulates? The volcanic eruption, blowing of dust and soil by wind, spraying of salts and other particles by the sea and oceans. What are the man-made sources? The ash from power plants, mining operations, smoke from the incomplete combustion, they also produce the particulates. Okay. Then what are the examples of the particulate release particles? The Fe3O4, calcium oxide, lead chloride, lead bromochloride, lead bromide. The organic part, that is polycyclic aromatic hydrocarbons, also produce the particulates. And how it is affected to the human beings. The metals cause more harm than the other particulates. This is because the metals are carcinogenic, that means it can cause the cancer, and the fine particles are more dangerous than the coarse particles. The particles lodged in lung causes several breathing troubles. For example, coal mines, the black lung disease, asbestos workers, pulmonary fibrosis, and emphysema of urban people are all due to accumulation of small particles. Effect on the materials. What are the effects of the particulates on the materials? Soot, dust, fumes, and mist are harmful for many materials. They are more harmful if they carry with them toxic substances. Then what are the effects on element? The particles in the air reduce the visibility. The particles in the air reduce the visibility, and they act as nuclei for the cloud formation. How to control? These are removal of particles matter from thus important. This is done by the 4 ways. What are the 4 ways? Number 1 is Cyclone Collector. That means the gas is forced into the light circular spiral. The centrifugal force produces force the particles to remove outward. 95% of the particle matter is collected in this way. The second one is by the electrostatic scrubbers also we can remove the particulates. By using the water scrubbers also we can reduce the particulates. By using the gravity settling chambers also, we can reduce the particulates. The next topic is about acid rains, how the acid rains are produced. Much of nitrogen oxide, sulfur oxides are entering into the atmosphere and they convert into nitric acid and sulfuric acid. This nitric acid and sulfuric acid combine with HCl emission and generate the acid rain. This acid rain causes extensive damage to buildings and sculpted materials of marble, limestone, slate, and mortar. These are pitted and weakened. They are converted into soluble sulfate. The calcium carbonate, it is reacted with sulfuric acid, it is converted to calcium sulfate as well as carbon dioxide and water. Already we know that the Taj Mahal is affected by the acid rain and its color is changes toward the light yellow. That means the pH of the acid rain is about 5 to 4.5. Okay, this is about the acid rain. The next is about the ozone depletion. This oxygen in the presence of the O2 in the presence of sunlight, it is converted to nascent oxygen. This nascent oxygen is reacted with O2. In the presence of M, it is converted to ozone. Okay. In the early 80s, the scientists reported a large hole in the ozone layer over Antarctica. The ozone level dropped by 30%. Subsequently, a similar hole was discovered over the northern hemisphere. A study by NASA is nothing but the National Aeronautic and Space Administration in USA, the scientists revealed that the ozone level decreased by 3% between 1969 to 1986. In June 1992, Japanese scientists announced that the ozone hole is 13 times wider in 1991 than it was in 1981. Okay. So here, in view of the rapid depletion of ozone layer occurring year by year, and international agreement was reached in 1987 at a conference in Montreal. This was signed by 34 countries. This is popularly known as Montreal Protocol. It was agreed upon this conference to take steps to reduce the cause of chlorofluorocarbons, CFC, responsible for ozone depletion by the 50% by the end of the century in June 1990. The developed countries agreed to 100% ban on the use of chlorofluorocarbon by 2018 at the conference held in London. They allowed a 10-year time lag for developing countries. This agreement was ratified in May 1992 and in completion implementation came into the effect on August 10th, 1992. Okay. The next is about last we are discussing about what is greenhouse effect. Among the chemical constituents present naturally in atmosphere, the carbon dioxide and water vapor absorb strongly the infrared radiation reaching the earth from the sun. Not only this, but they block effectively a large part of the radiation emitted by the earth. Therefore, the radiation is partially re-emitted to the earth's surface. Consequently, earth's surface is heated up. This phenomena is called as greenhouse effect. Thus, the carbon dioxide and insignificant non-pollutant species present in the atmosphere is of serious environmental concern. Increase in the carbon dioxide content of the atmosphere is ascribed mainly to the following two cases. The first one is deforestation. Number two is combustion of fuels. But the real increase in carbon dioxide percentage from the above two cases is only 60% of expected increases. This is attributed to the removal of a part of carbon dioxide by plants and part by the other sinks of carbon dioxide. The major sink for carbon dioxide is the ocean. Carbon dioxide is taken by the seawater and converted into bicarbonate ion. The other major sink is biomass. This converts carbon dioxide into carbohydrate by the process known as photosynthesis. So these are the other greenhouse gases. The relative contribution are shown in this figure. The 15% of chlorofluorocarbons, 17% of methane, and 60% of carbon dioxide, 2% of ozone, and 6% of N2O. These are affected to the greenhouse. Okay. The next is about what are the adverse result of greenhouse effect. This is the last one. Okay, these are the some of the results of greenhouse effects. The first one is a rise in temperature by even 1 degree centigrade is expected to affect adversely food production. The biological productivity of the ocean also decreases by the temperature rises. This is because of transport of nutrients from deeper layer to surface layers by the vertical movement. The sea level rises as a result of the transport rise. This may be as much as 2 meters. This rise is attributed to expansion of seawater and partial melting of ice caps. This rise in seawater level may lead to submerging a few island nations, for example, Maldives, Bangladesh, and coastal cities like Chennai and Goa. Okay, so these are the results of greenhouse. So this topic is completed, air pollution. So in this air pollution, we are discussing about some of the air pollutants. They are oxide as well as nitrogen oxide, sulfur oxide, hydrocarbons, particulates as well as carbon monoxide. Okay, the chapter is end. Thank you.